Hi my dear friends and my beloved lecturer Miss Nitya Anupam Parayasamy. It's honor for me today to stand from you deliver our presentation. First of all, I would like to introduce myself and introduce my friends. So my name is Durga Karupia. My metric number is 01DK20F2027 from DK to A. The second person in our team is Bhubaneswari Sridharan. She's metric number is 01DK20F2026. And the last person in our group, Shivanish Maya Chandran, is metric number is 01DK20F2022. Team roles and responsibilities. First, I present our introduce our group members. Then group members will do their tasks. Afterward, I will talk about team roles and responsibilities. And lastly, I will take part of sketchcraft. My second partner, Bhubaneswari Sridharan, will explain two parts of subtopic, which is introduction of definition and definition of the real life. The third group member, partner Shivanish Maya Chandra, will give about calculating of solution. Finally, he will finalize the summary part.
Hi madam, my name is Bhubaneswari Sridharan from class DKA 2A. My metric number is 01 DKA 20F2026. In maths, differentiation is one of the most important topics both academically and in terms of marks weightage. The concept of differentiation refers to the method of finding the derivative of a function. It is the process of determining the rate of change in function on the basis of its variables. The opposite of differentiation is known as anti-differentiation. Suppose we have two variables x and y, then the rate of change of x with respect to y, and it is denoted as d and dy per dx. The general expression of derivative of a function is x equal to dy per dx, where y equal to is any function. Differentiation is a technique which can be used for analyzing the way in which functions change. In particular, it measures how rapidly a function is changing at any point. In engineering applications, functions may, for example, represent the magnetic field strength of a motor, the voltage across a capacitor, the temperature of a chemical mix, and it is often important to know how quickly these quantities change. Product rule functions. If y is formed by multiplying the functions u and v, then dy per dx equal to u dv per dx plus v du per dx. Quantum rule functions. If y equal to u per v, where u and v are functions of x, then dy per dx equal to v du per dx minus dv per dx per v power of 2. Addition and subtraction of function. For functions that are formed by adding and subtracting of other simple functions, you can apply the simple addition and subtraction rule to find their derivatives. Generally, if y equal to fx plus gx, then dy per dx equal to fx plus gx, and if y equal to fx minus gx, then dy per dx equal to fx minus gx. Chain rule function. The chain rule states that if y equal to fu, where u is a function of x, then dy per dx equal to dy per du times du per dx. Differentiation is nothing but calculating rate at which a quantity changes. It's basically the slope of curve of a particular function. To give a simple example, the cooling of ice. We calculate change in temperature with respect to time. Similar other example, we will be rate of decay of radioactive elements, rate of growth of bacteria, deformation of an element along the length of. For all such example, of the real life, differentiation is a method to calculate required values at certain points other than one's easily measure, calculate, known. Most common use of derivatives is finding maximum and minimum values of a function. One might wish to calculate maximum profit, minimum loss of his business. Simulation software in engineering rely upon differential equations to solve difficult geometries. Various problems of nuclear decay, heat transfer, structural analysis involve differentiation.
Hi and hello everyone, my name is Sivanish Chandran and my matrix number is 01DKA20F2022, and now me and my team members going to do the calculation part, at where we got the question as y is equals to x power of 4 minus with 2x power of 2 plus with 3. So what we're going to do is we have to find the minimum and also maximum point of this function that has been given, and then we have to sketch their graph. So let us move to the calculation. Begin with our calculation, and where this will be the equation, and where y is equals to x power of 4 need to minus with 2x power of 2 plus with 3. So what we're going to do, the first step, okay, first step we're going to differentiate the equation y that have been given. So dy per dx will be the differentiation symbol to represent it, so that we will be get a differentiation equation like this. How we get this? Okay, let me explain. 4 need to times with the x, so we will be get 4x, and then 4 need to minus with 1. According to the formula, we will be get 3. So the first thing will be done, and then move on to the next thing. Negative 2 need to times with 2, so that we will be got negative 4x, and then the 3 need to be leave it as 0, so that we have don't value at that. And then we're going to do the next step, and where 4x cubed minus with 4x equals to 0, so we can make it as an equation, and where from the differentiation that we got, and then 4x in bracket x square minus with 1 will be get 0. So we can continue with the next step of the factorization of the differentiation we got from the y. Okay, so this will be the whole equation, and we're going to separate in the x values. The x values can be retained from this equation is x equals to 0, the first one. The second one is x equals to 1, and the third one is x equals to negative 1. So this will be the first, until the first step, and where the factorization can be done at here. Okay, now we can move on to the third step. So d2y dx2, this will be the symbol to represent the second order differentiation to the equation that we have been got, so that we will get 12x power of 2 need to minus with the 4. How do we get this? Okay, we can retain from here, and where 4x cubed minus with 4x, so that 3 need to times with 4, we will be get 12, and then the x will be remain at here. 3 need to minus with 1, so that will be get 2, and then negative 4x, after we differentiate it, we will be got 4. Okay, this will be the second order differentiation equation, and then we're going to replace it all the x values that we have been retained from that. So at here we have to replace 0, because this is the first value that we're going to replace it, so that we will be get 0 need to minus with 4, and we will be get negative 4, which can be identified as the maximum point. And move on to the second equation, which is the same equation, but we're going to replace it 1 inside of it, so that we will be get as 8. So 8 is a minimum value or minimum point can be retained. And then the third thing is 12x power of 2 need to minus with 4, and then we can here write as negative 1, because the third value will be the negative 1. So 12 need to times with the negative 1 power of 2 minus with the 4, we will be get the same answer also. So there is 2 minimum point and 1 maximum point based on the equation that has been given, which is the main one. Y is equals to x power of 4 need to minus with 2x power of 2 plus with 3. So there are 3 points, which is maximum point, can be about as -4, and 8, another 8 is minimum points. So 3 minimum points altogether at here, and we can move on to the next thing, and where we're going to write about the stationary point. Okay, at stationary point, okay, we was used 0 and -4 was the answer. So this is the very first one, and then following with -1, because we have been used -1, the answer is 8. So this is the second stationary point, and the very last one is we was used or we was retained 1, and the answer is 8. So altogether we will be got 3 stationary points towards this equation. And now I'm going to do the next thing, which is dy over dx. The one after we differentiate, we will be get this one. So I'm going to replace 0 inside of the equation from the main one, which is y is equals to 0, 4 minus with 2, 0 power of 2 plus 0. So we will be get y is equals to 0 because x power of 4 is equals to 0, minus with 2 times with 0 power of 2 will be get 0, and plus with 3, so y is equals to 3. And then following with the next one, when the x value is equals to -1, okay, we're going to replace the -1 inside of the equation, which can be replaced at the place of x, so that we will get the answer will be 2. Okay, so the third one is when the x is equals to 1, so we're going to replace the x values as 1 inside of the main equation, so that we will be get 1 minus 2 plus 3, so the final answer will be 2 according to our calculation. So according to our calculation, we can notify a statement and where 0, 3 and 1, 2 are the maximum points, and then following with 1, 2 will be the minimum points. So the calculation until here is over. To get we know how about the graph, so let us move on to the graph question, and my friend will be discuss about how to sketch the graph according to the points that have been recorded and using the formulas.
Hi, my name is Vuka Gabriel. My metric number is 01TK20F2027. So now I will explain part of graph. So come, let me explain. So friends, we start to sketch the graph. So the first stationary point -1, the second stationary point 1, the third stationary point 0, -4. So we start the first stationary point. Okay. The first stationary point -1, and the second stationary point 0, -4. The last stationary point 1, 8. So we get minimum point and we get to U shape.
So now I'm going to talk about the summary. What I can be summarized from the chapter 2 differentiation from engineering mathematics 2 is about the derivative dy dx of a function y is equals to fx. Tell us a lot about the shape of a curve in a graph that should be. In this section, we will discuss about the concepts of stationary points and increasing and decreasing the functions in a graph. However, we will limit our discussion to functions y is equals to fx which are well behaved. Certain functions cause technical difficulties, so we will be concentrate on those that don't. So in our calculation, based on the calculation that have been done, we got 3 kind of points. The very first one is the maximum point, which can be replicated from -4, and then following with 8, which is twice, which is minimum point as 2. So in this calculation that we have been done, we can find or able to find that 3 kind of points to shape of our graph. So there are three types of stationary points. They are relative or local maxima, relative or local minima, and horizontal points of inflection. Relative of local maxima and minima are also called to indicate that they may be maxima or minima only. The first derivative can be used to determine the nature of the stationary points once we have found that the solutions to dy dx is equals to 0. So I think that's all from us. Thank you so much for listening.